And welcome back to Teacher Gimbal channel. Today I'll be going over Illustrative Math Geometry Unit 1, Lesson 14 Practice. If you like this video, please make sure to like and subscribe by hitting the button down here. And if you like these videos in general, if you subscribe to my Patreon and send me a message, I can make you any videos you want on any topic. So you can personalize those videos and get the video lessons that you need and the timeline that you need it by subscribing to my Patreon. Let's get started. Problem number 1. Draw an image of the quadrilateral ABCD rotated 120 degrees counterclockwise around point D. So there's three things you're always going to look for when you're doing a rotation. The first thing is how many degrees are we rotating? The second thing is direction, and the third thing is around which point. So we have all of this information in the question. Remember, if this is our clock, clocks move that way, so that direction is clockwise, this direction is counterclockwise. So we know we are moving counterclockwise around point D. D represents our center of rotation. And I'm going to start by looking at this line segment right here. We know he's going to go this direction because we are going counterclockwise. And now we know each of these triangles have a 60-degree angle because they're equilateral triangles. So 120 degrees, well, that's about 30, plus another 60 is about 90, plus another 30 puts us over here. So this segment, he's going to stay the same length and in size, and I'm just estimating here, goes to right there. D is going to stay where he's at. So that segment, he rotated all the way down there. Let's go ahead and do the second segment. This segment right here, he's going to rotate counterclockwise, which is that direction, and he's going to do two full triangles, 1, 2. And he's 2 lengths long, so he's going to be 2 lengths long, and that's going to be C prime over there. Now, if you're doing this on a piece of paper, I highly recommend you do it with a piece of tracing paper because it's difficult to do this without tracing paper. But I see these two guys, they rotated into that angle, so C prime. Let's erase this so it's clear. C prime moved there, A prime moved there. And I can look from this, and I can say, well, AB goes a little bit out, so he's going to go out like that, and BC connects right there. So I had to estimate here because I don't have tracing paper, but you can see how this shape rotated. So A lines up with AD, AB lines up with A prime B prime, BC lines up with B prime C prime, and DC lines up with D prime C prime. So we can see that rotation, and this whole shape moved 120 degrees counterclockwise around point D. So I highly recommend you use tracing paper. I also always remember you're going to need 3 pieces of information for every single rotation. All right, let's go on to the next question. Problem number 2. There is an equilateral triangle ABC inscribed in circle D with center D. So we have a circle. We have an equilateral triangle, ABC, which means all of our sides are the same, in which case each side is 60 degrees. And we have A, B, C, and the center is D. What is the smallest angle you can rotate ABC around D so the image of A is B? So we're looking to rotate A to B. Now, what we're actually trying to do is we're looking for this thing, and we call it rotational symmetry. That means when we rotate a shape and it lands upon itself. Because when we rotate this triangle around from A to B, this triangle is still going to look the same as it does in this image. Now, the way you determine rotational symmetry, or how to get A to B, is we're going to say 360, and we're going to divide it by the number of sides. We have 3 sides. That means it's 120. So this works for regular polygons. So to get A to B is going to be 120, B to C would be another 120, and then A back to A would be 360 degrees. And we determine because our rotational symmetry is 120 in this case. So it takes 120 to do one turn where it still lands on the same, looks the same. Once A goes to B, B goes to C, and C goes to A. All right, next question. Problem number 3. Which segment is the image of AB when rotated 90 degrees counterclockwise around point P? So we're talking about segment AB, which is this guy right here. We're rotating 90 degrees counterclockwise, so he's going this direction around point P, which is over here. And We got the angle, we got the direction, and we got the point. Well, I'm going to say, when I do this, I'm going to say A is going to get rotated. He's going to get rotated in that direction, and he's going to get rotated that same length. So A goes to G because that's 90 degrees. And that's how I look at rotations around a point. That same distance, the distance from P stays the same. So if A is 2 blocks from P, we'll rotate him 90 degrees, he stays 2 blocks away from P. So let's go ahead and look at B, and let's do it in a different color. If we have B, well, B is this distance from P, and we know we're going to rotate 90 degrees, so I draw that 90-degree angle counterclockwise, and we can easily see that B is going to go to F. So when we rotate AB 90 degrees counterclockwise, we end up with segment FG. And that's our answer. If you have tracing paper, I would recommend you go ahead, put it up against your screen, and try to see how it works that way as well. Problem number 4. The semaphore alphabet is a way to use flags to signal messages. Signal messages. Q. Here's how to signal the letter Q. Describe a transformation that would take the right-hand flag to the left-hand flag. So the right-hand flag is going to go to the left-hand flag. Our center of rotation in this case, that's going to be right there because that's where the arm is moving from. So we have the direction, we have the center of rotation, and we're just going to estimate. This looks about 120 degrees, but that's what we're going to estimate the degree of rotation. So that's the 3 things that we do. So if we rotate the right flag 120 degrees clockwise, he's going to land right there. And what do we need to do in order to make sure the right flag lands on the left flag? Well, we're going to have to reflect him. So we would reflect him over the line of reflection, which was this line right here, highlighted in blue. And the right-hand flag is going to end up on the left-hand flag. So the sequence of transformations is a clockwise rotation 120 degrees around point P, and we've named him P, and then a reflection over the line of reflection, which is the guy's right hand, or the guy's left hand, because I guess he's facing us. All right, let's go on to the next question. Pause the video or re-listen if you need to go over on exactly how I did this. Problem number 5. We've got to zoom out a little bit for this one. Here are 2 polygons. Select all sequences of translations, rotations, and reflections below that would take polygon P to polygon Q. So first we say polygon P is going to polygon Q. And I'm going to change colors just because I don't want to mix up my colors. So P is going to Q. And it's always important to notice which ones are image and which ones are pre-image, because that changes. And Q to P would be different sequence of transformations. So rotate 180 degrees around point A. Now you might notice with the rotations around that are 180 degrees, we don't actually have a direction. That's because going 180 degrees one way is the same thing as going 180 degrees the other direction. So when we have a 180 degree rotation, you're not going to see a direction. So, well, let's start with one of our segments. If BA is rotated 180 degrees around A, BA is going to line up on the other side right there. Does BA correspond to AJ? That looks like it does. Now let's look at a different point. So that looks good so far. But what about point P or EA? Well, EA rotated 180 degrees. He's going to land over here. And we need EA to land right there. So even though one of the segments does line up, with the rotation of 180 degrees, we see not all the segments line up. So we're going to cross them out. And this is why it's important to check your rotations for all segments. B, translate so that A is taken to J. So A slides to J. I like that. And then reflect over line BA. So if we're looking at this, A slides, which means this whole shape is going to slide. And he's going to look something along the lines of, and I'm just sketching here, but it all slid all the way up, I guess, kind of more like that. So A goes to J, B goes to A, E is going to come up here. And then we have a reflect over line BA. Well, A slid up over here, and B ends up over there. And when we reflect, it does look like the images line up to each other. So yes, we're going to say this one is correct. All right. C. Rotate 60 degrees counterclockwise around point A and then reflect over line FA. So we're going to rotate 60 degrees counterclockwise, which is going to be right there. So BA is going to rotate, and he's going to end up right there. B's going to be there, A is going to stay, and then we're going to flip over. Now, if you notice, BA lines up on FA. When we rotate, CD is going to end up somewhere over there, and he's going to flip and be all the way up here, which means our images do not line up on each other, so this would not work as a sequence of transformations that takes polygon P to polygon Q. All right, D. Reflect over line BA and then rotate counterclockwise around point A. So first, we're going to reflect this way, which means AE is going to come here. We're going to come up over there. He's going to come down over here, and it's going to look something like that. Okay, we've reflected over line BA, and then we rotate it around point A. I can clearly see no matter which direction I rotate, well, I'm rotating counterclockwise, 60 degrees is not going to bring me where I need to be. But if I do the same reflection, reflect over line BA, and then translate by the directed line segment BA, this guy, he's going to slide right up on top into where we need him to be. So E is a correct answer. The more you do of these questions, the easier it's going to get to kind of see the visualization that you do on your own. And I always recommend, especially with rotations, to pull out your tracing paper to visualize this better. All right, problem number 6. Reflect over line BA, draw an image of figure ABC when translated by directed line segment U. Label the image A as A prime, the image of B as B prime, and the image of C as C prime. Explain why the line containing AB is parallel to the line containing A prime, B prime. So we're going to translate each point this much. Now, if you're doing this by hand, you need to use a ruler. I'm not doing this by hand, so I'm just going to estimate. So C is going to go the length of U, that represents U, and he's going to bring C prime over there. B is going to go the length of U, the same direction. He's going to bring B prime right about over there. And A is going to go the length of U, the same direction, and he's going to bring A prime right about there. I'm going to connect those 3 points, and I have now translated my segment. Now, why is AB parallel to the line containing A prime, B prime? And I'm going to mark parallel. Well, when you're translating a segment, the slope of the segments never change. So that means the slope here and the slope there are the same. And when you have 2 segments with the same slope, they're always parallel. And that's something that's specific to translations. That's not special to rotations or reflections. So the slope of your translated segments is always going to remain the same. Therefore, AB is going to be parallel to A prime, B prime. All right, problem number 7, our last question. There is a sequence of rigid transformations that takes A to A prime, B to B prime, and C to C prime. The same sequence takes D to D prime. Label D prime. Well, D is somewhere between B and A, which tells me D is going to be somewhere between A prime and B prime. D is closer to B, so D prime is going to be closer to B prime. And we're going to put them right about over there. And that's it. If you have any questions, please put them in the comments below. If you like this video, make sure to like and subscribe, and I look forward to seeing you in the next one.